Good day everyone, we're the Group 5 and today we're going to tackle about probability concepts and application. Introduction. Life is uncertain. We are not sure what the future will bring. Risk and probability is a part of our daily lives. Probability is a numerical statement about the likelihood that an event will occur. So, what is probability? Do you guys have any idea what is probability? Okay, so probability means possibility. It is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability has been introduced in math to predict how likely events are to happen. The meaning of probability is basically the extent to which something is likely to happen. This is the basic probability theory, which is also used in the probability distribution, where you will learn the possibility of outcomes for a random experiment. To find the probability of a single event to occur, first, we should know the total number of possible outcomes. So guys, I'm not going to explain further what is probability since the meaning itself is really easy to understand and I know you guys already have a background about probability. So, there are two basic rules of probability. First, the probability P of any event or state of nature occurring is greater than or equal to 0 and less than or equal to 1. And the second one is the sum of simple probabilities for all possible outcomes of an activity must equal to 1. So I'm not going to explain this one because later on our examples you can see that these two basic rules of probability has been applied. So here are the types of probability. Originally there are only two types of probability, but objective approach has been categorized into two. First, objective approach or relative frequency approach. The second one is objective approach or classical or logical method, and the third one is the subjective approach. So, objective approach or relative frequency approach, P event is equal to the number of occurrences of the event total numbers of trials or outcomes. Example for this is the Diversey paint. Its historical demand for white latex paint at 0, 1, 2, 3, or 4 gallons per day, and its frequencies has been observed over the past 200 days. So the table shows the quantity demanded or gallons, the number of days, and the probability. The quantity demanded or gallons are 0, 1, 2, 3, and 4, and the number of days are 40, 80, 50, 20, and 10 with a total of 200. So the probability of 0 gallons with 40 number of days is equals to 40 over 200 or is equals to 0.20, and the probability of 1 gallon with 80 number of days is equals to 80 over 200 or is equals to 0.40. The probability of 2 demanded gallons with 50 number of days is equals to 50 over 200 or 0.25. The probability of 3 quantity demanded or gallons with 20 number of days is equals to 20 over 200 or is equals to 0.10. And the probability of 4 quantity demanded gallons with 10 number of days is equals to 10 over 200 or 0.05 with a total of 200 over 200 or is equals to 1. So as what I have said a while ago, the rule of probability has been applied to this example since the total sum of this probability 0.20, 0.40, 0.25, 0.10, and 0.05 is equals to 1, which is the individual probabilities are all between 0 and 1. So another type of probability is the objective approach or classical or logical method by which it performs a series of trial. For example, getting ahead when tossing a coin, which is expressed as 1 over 2. 1 here is the number of ways of getting ahead, and 2 is the number of possible outcomes. It's either the head or the tail. So there is 1/2 possibility or 50% of getting ahead when tossing a coin. Another example is getting a spade card from a deck of cards, which is expressed as 13 over 52. 13 here is the number of chances of drawing a spade, and 52 is the number of possible outcomes, which has the probability of 1/4 or 0.25 or 25%. So the third type of probability is the subjective approach. It is when logic and past history are not appropriate, probability values can be assessed subjectively. It is based on the experience and judgment of the person making the estimate. For example, opinion polls, it is to determine the election returns. The second one is the judgment of experts. And the third one is the Delphi method, or a panel of experts is assembled to make their predictions of the future. So when we say subjective approach, it is of course the opposite of the objective approach, since objective approach regards to a valid evidence, and the subjective approach only refers to a personal perspective. Mutually exclusive and collectively exhaustive events. Events are said to be mutually exclusive if only one of the events can occur on any one trial. So when we say mutually exclusive, these describe two or more events which cannot happen simultaneously or cannot happen at the same time. For example, is when tossing a coin. This will result in either a head or a tail. You cannot expect a two result at the same time. Same as when rolling a die, it will result one from its possible outcomes. Mutually exclusive and collectively exhaustive events. Events are said to be collectively exhaustive if the list of outcomes includes every possible outcome. So when we say collectively exhaustive, it means that you're expecting at least one of the possible events to occur. For example, both heads and tails as possible outcomes of coin flips, and all 6 possible outcomes of the roll of a die. So with the example, it means that you're not expecting a specific event to happen. Thus, you're expecting all the events which can possibly occur.
So, good afternoon everyone. Moving on, now we have to discuss unions and intersections of events. So, intersection, the set of all outcomes that are common to both events. Intersection of sets for two given sets is the set that contains all the elements that are common to both sets. For the symbol for the intersection of sets is kanaang murag inverted dira ngayon nga naa sa PPT. So muna ang atoang nga kanaang symbol for intersection of sets. So for any two sets A and B, the intersection of sets is represented as A intersection of B and is defined as the group of elements present in set A that are also present in set B. So that is known as the intersections of sets. So kanina yung intersection of kuanday sets ay kailangan kanang kuan siya kanang present ang kung unsay elements nga present sa set A kay dapat present po siya also present sa set B. So dapat naa sila common sila both mo ba? Alagi present kung unsay naa nga elements sa set A mo sa napuna siya sa elements sa nga present po siya sa elements sa set B. Also, okay, so further kanaang kuan para masabtan na to ang kanaang intersection of events or intersections of sets. So I will give some example. So for example, ang set A na to nag-contain siya og elements of 1, 2, 3, 4, and 5. Muna siya tong set A. Sa tong set A is 1 to 5 nga numbers. Then sa set B kay nag-contain siya og elements nga 3, 4, 6, and 8. So what is the intersection of sets A and B? So to find the intersection, we need to find out which elements are common to both sets. So tan-aw na to kung asa dapit naa sila in common sa set A o set B. So both sets contains 3 and also it contains 4. So therefore, the intersection of sets A and set B is 3 and 4. So that's how you can find the intersection of two sets. Kung unsay common sa set A or sa set B nga imong nakita, so muna siya ato ang kanang answer for intersections of sets. So dira na to mahibaw-an, dira ta makadetermine kung unsa ang kanaang asa dapit ang intersection between the two sets. So let's go some more examples para sa kanang intersections of sets. So example natay we have set D. Example, set D na to nag-contain siya og elements nga A, B, C, D, E, F, G, H, I. So, A hantod sa I nga kanaang letters. Then, sa set F, nag-contain siya og elements nga vowel letters, katong A, E, I, O, O. So, determine the intersections of set T and F. So, by determining, so, kay bawa naman taon sa pag-determine sa, so, intersection, kay kailangan ka ng common siya sa both sets. So, unsa may naa nga common sa both sets. So, ang naa nila is E and I is common to both sets. So, this is the intersections of D intersect F. So, inanaon siya pag-determine sa intersections. So, I hope you understand kanang clearly about sa intersections of events and intersections of sets. So, moving on, we have the unions of events or unions of sets. So, union, the set of all outcomes that are contained in either of two events. So, the union of events A and B denoted as A union B. So, kanang atong symbol for union is kanaganing U dira nga kanaang kuan. Ganyan ka inverted U man to sa karon kay U na gid siya nga letter, pareha siya og barog sa U nga letter. Yeah, muna siya ato ang symbol for the union of union. So, the union of events A and B denoted A union B is the collection of all outcomes that are elements of one or the other of the sets A and B or both of them. So, it corresponds to combining descriptions of the two events using the word or. So, kaning unions, kay kung ano siya, combining na niya siya, kung unsay na sa set A, i-combine mo na siya sa set B. So, ganina kay, ato ra may determine sa kung asa sila dapita ka na ang kuan, asa sila dapita ka na ang the same ganang kuan sa intersection, asa dapita sa intersection na sila the same kuan elements. Karon sa unions kay tanan na siya combining na niya ang kuan, combining the collection of all outcomes that are elements of one or the other of the sets A and B. So, i-combine na to siya ang sa union. So, combining na niya sa union. So, let's say that, ang example, ano niya sa, let's say that, example, set A contains the elements of, sa union of events, samples. So, sa set Z, natay 1, 2, 3, and 4 nga elements. Then, sa set N, natay 3, 4, 5, and 6 nga elements. So, what is the union of these two sets? So, the union will contain everything in both sets. So, kani sa tanan, imo ni siyang i-combine tanan, like, i-determine din mo kung asa dapita ang unions of sets diri. So, imo na siya nga ikanaang kuan, i-combine tanan. The union will contain everything in both sets. But, iba kabantay mo sa set Z and set N kay na the same number dira nga 3 and 4. Na 3 and 4 dira. The same na sa ang set Z na 3 and 4. Ang set N na po siya 3 and 4. So, kana siya, di na to siya i-listed kaan, kanang kaduhaon na to siya pag kanang suwat. Dapat kausara na to siya. Kung ma-determine na tag-union, dapat kausara nga to ang kanaang kausara ta masuwat niya. 3 and 4 will not listed twice, only once. So, the union of sets, so ang union of sets ani, Z union of N is equals to the elements of 1, 2, 3, 4, 5, and 6. So, di mo dublihon ang 3 o ang 4. Dapat usa gina siya nimo i-list kung naay magkapareha. So, another example. So, we're gonna write everything in both sets. So, sa union kay, we're gonna write everything in both sets but only listed once. Kung naay makakita ka ganang same dira nga number, so dapat kausar na mo siya. Di mo siya dublihon pag ang SWOT. So, another example kay, we have set C. In set C, natay elements nga 3, 5, 9, 11, and 13. And sa set D, kay natay 2, 3, 6, 8, and 12 na elements sa set D. So, determined. So, now, let's find the union between C and D nga sets. So, all we're gonna do is just write all the numbers in sets C and D. So, let's put it in ascending order. So, ato ibutan siya in ascending order. Unahon na to ang 2, then 3. So, double 3 man na sa kay sa set C na pre 3, then sa set D na po siya 3. So, igabot diri, i-determine na to, kausahon na to siya, o kana ang suwat ang 3. Next is 5, 6, 8, 9, 11, 12, and 13. So, muna ato ang union of sets sa C and D nga elements, ang nga sets. So, inanaon na siya pag determine natuon na siya pag determine ang union of sets. Then sa intersections of sets, kung asa sila dapita kanaang kuan. Kung asa sila dapita kanang elements is kanang present. Kung asa dapita present both yun sa sets nila. Mura imong i-answer ito. Pero ano sa union kay combining na ni siya. I-combine mo tanan nga kanang unsay makita nimo sa set A or set B baron dira dayon dapat ang imuhang number kausara nimo nga kanaang i-list di nimo siya ibalik-balikon. So muna siya ang kuan. Set muna siya ang intersections and unions of events or sets. So moving on, we have the probability rules. General rule for union of two events, the additive rule. So we have the formula given. The formula is read as the probability of event A and B. A or B is equal to the probability of event A plus the probability of event B minus the probability of event A and B. So union of two events, a 7 or heart. So we have to use the given formula. The PA or B is equals to PA plus PB minus PA and B. So first we have to determine what is the value of probability A here. So the probability A here is manish kaning 4/52 plus the probability B is 13/52 minus the PA and B which is the value of 1/52. So 4 plus 13 is 17 minus 1, that's why we came up with the answer of 16/52. So moving on, independent events. One event has no effect on the other event. So we have the formula PA and B is equals to the probability of A times the probability of B. So example here is for a fair coin tossed twice. So in event A, that ahead is the result of the first toss. So kanang wata kay ba og unsay ka na in the first toss nimo kay ka na ang kuan head ang makuha, right, or tail. So ingnon na we have kanang kuan as if as ang event A na to kay head in the result of the first toss. Then event B, that the head is the result of the second toss. So we have 0.5 as kuan result of the first toss kay dayon ang ato ang kuan probability B naputay 0.5 nga result for the second toss. So we have 2 times both the PA times PB, which is 0.5 times 0.5. So that's why we came up for the answer of 0.25. Next is independent events. A bucket contains 3 black balls and 7 green balls. So we have draw a ball from the bucket, replace it, and draw a second ball. So we have 10 balls. All in all, we have 3 black and 7 green. So first is the probability of a black ball drawn on first draw is. So the probability of black ball is 0.30. So we have that PB is equals to 0.30. Second is the probability of 2 green balls drawn is. So we have the 2 green balls, which is probability G times the probability of G, which is green balls. So 0.7 times 0.7 is equals to 0.49. Third is the probability of a black ball drawn in the second draw if the first draw is green is. So we have probability of B. Probability B is equals to 0.30. The probability of a green ball drawn in the second draw if the first draw is green is 0.70. So we have PG dira is equals to 0.70, or the probability of G is equals to 0.70. So dependent events. An urn contains the following 10 balls. So we have the 10 balls. 4 are white, then lettered. Then next is second are white and numbered. 3 are yellow and lettered. 1 is yellow and numbered. So probability of kuan white and lettered, that's 4 divided by 10 is equals to 0.4. And the probability of white and numbered is 2 over 10 is 2 divided by 10 is equals to 0.2. Then probability of kuan white only, white balls only. So there are 6 divided by 10 is equals to 0.6. Then probability of yellow balls only, that is 4 divided by 10 is equals to 0.4. Then probability of yellow and lettered, 3 divided by 10 is equals to 0.3. Then probability of yellow and numbered, 1 divided by 10 is equals to 0.1. Ngayon, probability of lettered only, which is 7 divided by 10 is equals to 0.7. Then probability of numbered balls is equal to 3 divided by 10 is equals to 0.3. So here are the dependent events. The 4 balls white and lettered, so 4 divided by 10. Probability of white and numbered, 2 over 10 or 2 divided by 10. Probability of yellow balls and lettered, 3 divided by 10. And probability of yellow and numbered is 1 divided by 10. Dependent events. The conditional probability that the ball drawn is lettered given that it is yellow. So muna siya ang kanang formula for katong ang ball na to is lettered and the color of the ball is yellow. So we have P, probability of lettered over the yellow is equals to probability of YL divided by PY is equals to 0.3 divided by 0.4. That's why we have 0.75. So we can verify probability YL using the joint probability formula. So we have 0.75 as the PYL times the 0.4 for PY is equals to 0.3.